Okay, this is a model for a wheelchair car using hand gesture movement. Okay, the components are Arduino Uno, a breadboard, proximity sensor, and accelerometer to measure the tilting of the hand, so we can move according to each hand gesture. When we tilt right, we go right. When we tilt left, we go left. Then we use the two DC motors for the movement of the wheels, and use the edge bridge to control the motor movements. Each motor has two inputs, and the edge bridge takes the VCC from the Arduino Uno. Two cables for the VCC and one for the ground. Motor A takes two inputs, VCC and ground. Motor B takes two inputs, VCC and ground. And the edge bridge has 6 inputs, 3 for each motor. One enable for each motor, meaning that when it's 0, the motor stops. When it's 1, the motor goes on. And input 1 and input 2 for each motor. Input 1 states the direction, the counterclockwise direction. Input 2, when it's set to 1, moves the wheel to the clockwise direction, and the same for the other motor. That's all.
Hello everyone, I'm Haneen Ahmed and I have worked on the edge bridge of the project. The hardware of it takes 4 inputs and 2 enables to enable the motor. The 4 inputs, I have defined them in the code motor A and motor B. Motor A takes 2 inputs and to emit motor B as well. For motor A, I have defined the 2 inputs of it as direction 1 pin A and direction 2 pin A, and I will show you in the code how. And motor B, direction 1 pin B and direction 2 pin B as well. And connect them to the connect those pins to the Arduino. And I have defined them in the setup as an output. I will show you how. And then to make the motor works, I have to set one of the directions, one high and the other low, for motor A and motor B. And I am changing their order according to my preference, if I wanted to move forward, backward, left, right, or whatever. And that's all about the edge bridge, and I will show you the code now. And thank you. I will show you now how the edge bridge works. The 4 inputs in the edge bridge are direction 1 pin A, direction 2 pin A, direction 1 pin B, direction 2 pin B. For pin B it's for motor B, and for pin A it's for motor A. And those numbers are their locations in the Arduino. Okay, and the setup, in the setup method I have defined them as an outputs here. And then in the edge bridge I have to, for motor A, I have to set one of it high and the other low, and the same for motor B, because if I set both of them high or both of them low, it's like telling it move in the opposite, move in both direction at the same time. So I have to set one high and one low for each input, for each motor, sorry. And I'm changing its order according to my preference, if I wanted to move forward or backward. So now here is the forward. I set them like that: high, low, low, high, low, high, low. And for the backward direction, low, high, low, high. And for the right direction, high, low, low. And for the left direction, low, low, high, low, because I want the motor B to stop. Okay, to let motor A only works to move right, and the opposite here. I let motor A stops and motor B works to move to the left direction. And that's all about edge bridge. Thank you.
Hello everyone, this is Ahmed Amr and I'm here to let you know more about the accelerometer. As Yusuf, our friend, has introduced you to the accelerometer, let's take a closer look on how it works and how we implemented it in our project. The hardware itself is pretty simple. It just takes VCC and ground and 3 signals, which are X out, Y out, Z out. Let's dive into the code. We have constant in X out, which is A in pin A2 in our Arduino in our case, Y out in pin A1, Z out in A0. And we have also variables X ADC value, Y ADC values, Z ADC values, which we will contain the value of the signal we read from X out, Y out, and Z out. And during my programming period, I realized that I have to test first the steady state values, which I use serial.print X and printing X ADC. Of course, after I do this, analog read X out or analog read Y out or analog read Z out. So I print all the values so that I can see them clearly, and also I add delay to give the compiler time to show the values clearly for me. And after I printed it, I realized or I concluded from the values that when I go left, the value of the X increases. When I tilt the accelerometer left, the value of X increases, X ADC value, and Y stays the same. And when I tilt right, the value of the X decreases in this range. So I included this in the check, and Y stays the same. And when I tilt backward, the X stays the same, but the Y increases. And also when I tilt forward, so that the car will move forward, the value of X stays the same, and the value of the Y decreases. So that I made all these checks depending on the results I got from the signals, and else, which is a steady state that I am not tilting my hand, I will stop the car.
Hello everyone, my name is Mustafa Nawar, and today I will talk more about the proximity sensor. As my colleague Yusuf has introduced you to the proximity sensor, let's have a closer look on how we implemented it in our project code.
As mentioned before, is pretty straightforward. This is the code to our whole project. The proximity sensor takes a VC ground and signal that we will read to know whether there is an obstacle in front of the car. Let's take a look at the code to see how it is implemented. We here first define the constant and proximity sensor to pin number 6, connected to the Arduino, which are in our case is pin 6. Then here in the setup, we can read the signal of the proximity sensor coming from pin 6 and from pin 6. And whenever any of the move methods are called, forward, backward, left, or right, it first checks on the signal coming from the proximity sensor. If the signal is equal to 0, then it calls the method stop car, which moves the car to the steady state. Else, it continues executing code normally to move forward or left or right. Thanks for your time.